Assalamu alaikum everyone. Okay, let me read your messages. Add maths, inshallah, this week. So I plan on doing streams regularly now till December and in December also for midterms. So don't worry. Add math streams are also lined up. Really need more of these streams for 0580 for the newly added topics. Yeah, thank you for that. I came back from Umrah a few weeks back. I guess you probably noticed from the haircut. Acha, what else? Really need more of these. Yeah, so for new topics, and I made a video on how to find exact trigonometric values. I am streaming surds and rationalization. Sorry, that's the same thing. Surds and exponential growth and decay. So that's something that has been added in IGCSE. Surds is what has been added. So we'll do that inshallah on Wednesday. Okay, so Wednesday I'll be streaming that. Transformation. Okay. Thank you. Thank you. Anyway, so today we are going to do probability. And I understand probability is a pain point for a lot of students. So let's try and fix that. अच्छा, let me know what topics of AdMaths you guys want me to stream. अच्छा देखो, इस तरह से तो ना कभी वो ख्वाहिशें आप लोगों की ख़त्म नहीं होंगी. ठीक है, मैं एक टॉपिक स्ट्रीम का, I'll be streaming topic X, you guys will be saying stream topic Y. So let's start, okay, and I'll try and be more frequent with my streams and try and make sure that we do as much as possible. Okay, so there are two worksheets which you guys will find in. You guys will find these two worksheets. There will be a link in the description, okay, and you will find two worksheets which will be of probability. Okay, mostly the questions that I will be streaming today will be paper 1 questions, okay, non-calculator questions, but a good idea would be to have them downloaded with you. Okay, now we are going to do concepts as well as past papers. Okay, so let's start with concepts first. Let me just open up my notes so I don't forget anything. So what's the weather situation like in your respective cities? Has the smog cleared? और स्कूल्स खुल गए आप लोगों के वापस से? Sir, when should syllabus of math be? देखो, you should have at least 6 weeks to yourself for doing past papers. Okay, and I'm talking about yearly past papers. Same time, tomorrow, Wednesday, same time. Increase my volume? Yeah, sure I can. There you go. Yeah, there may be some internet issues. Been having those today. I don't know why, but I guess you will have to put up with it. Okay. Khair, I've increased the volume anyway. So anyway, let's start. Okay. So probability. Let's write down today's date and let's start. Is it because of that? Is it because of ideas? कहीं का नहीं छोड़ा यार. रोड भी बंद कर दिया है, इंटरनेट भी बंद कर दिया. खैर. So today is the 18th of November. Let's get to work. Now, what is probability by definition? देखें, all of probability will revolve around just one formula. Okay, all of probability, mark my words, all of you will notice will revolve around just one formula. And what is that formula? Basically, favorable upon total. Okay, that formula is favorable outcome divided by total outcome. Just a minute here. Just a second. इतने दिनों बाद स्ट्रीम कर रहा हूँ ना, भूल गया हूँ how to set things up. Why am I not using PDF Expert? PDF Expert वाले updates ही नहीं निकाल रहा है, तो अब मैंने कहा भाई I'm gonna use GoodNotes, और GoodNotes की lately जो updates आई हैं काफ़ी fit आई हैं. Okay, everything's sorted now. Okay, I know there may be a lag. Let me see what I can do to fix it. Unfortunately, not much. So, okay, I guess we'll have to put up with it. Okay, so बीच में most likely सही हो जाएगा. So, probability. What's probability? Let's finally start. Probability. अब देखो, the question of probability can come in either paper 1 or in paper 2. Okay, and it can be around 6 marks, 8 marks, anywhere around that. Okay, sometimes even more, depends on the nature of the question. Okay, but what exactly is probability? By definition, it is the chance of an occurrence of an event. Okay, most likely it's going to be a non-calculator question. Okay, most likely it's going to end up in paper 1 of O levels or paper 2 of IGCSE. So that's what it is. It's chance of an occurrence of an event. Now, how do you find out probability? This is how we calculate probability. Probability is equal to favorable outcomes. Okay, whatever it is that you're trying to calculate the probability of. Okay, how many times does that happen? Divide by the total number of outcomes. Okay, that's what probability is in short. Now, how can you express probability? Probability can be expressed in 3 ways. Number 1, you can express it in decimal. Okay. Number 2, you can express it in fraction. Okay, you can express it in fraction form. And number 3, you can express it as a percentage also. Okay, so if let's say you give your answer in decimal and at the back you see it's expressed in fraction, don't freak out. It's not like you've done something wrong or if your answer is incorrect. There are just multiple ways of expressing the same thing. Now, the main concepts that we need to focus on when dealing with probability is number 1, sample spacing. Okay, so we're going to learn about that. Now, what is sample spacing? Sample spacing is basically listing all possible outcomes. Okay, when we do sample spacing of something, what we do is we list all possible outcomes. Okay, and when we list all possible outcomes, it's easier for us to calculate probability. Okay, so that's what sample spacing is. Okay, then next is tree diagram. Now, tree diagram is perhaps the backbone of probability. Okay, tree diagram is also a form of sample spacing because it helps us figure out all the possible outcomes. Okay, so tree diagram is something that we're going to be dealing with, could be with or without replacement. Okay, could be with or without replacement. So we're going to learn how tree diagram works, what's the benefit of a tree diagram. That's what we're going to learn, inshallah. And then comes the final is another form of tree diagram, but here we will have 2 separate categories. Okay, so we'll learn how to make a tree diagram of 2 separate categories. Okay, you guys will find out once we're doing questions. Okay, now let me tell you guys something about probability, and this applies to a lot of topics also. Well, you can learn all the concepts for so long. Okay, you can spend a lot of time learning concepts, but majority of the learning is done by solving past paper questions. So even if you think that your concepts are, let's say, a little bit shaky, that's okay, nothing to worry about. Start solving past papers. Okay, solve a lot of past paper questions, and with the help of that, you'll be able to improve your concepts. Okay, so that's how it works. Don't get fixated on, or don't try and wait that, oh, once I reach a point where I have my concepts covered, I'm gonna then solve past paper questions. ऐसा नहीं है. Just start solving past paper questions and your concepts will get stronger. Okay, so let's start with sample spacing. Now, what is sample spacing? Like I said, sample spacing is basically when we list all possible outcomes. Okay, so what's the sample spacing of a coin toss? Okay, if I toss a coin and I want to see all the possible outcomes, okay, that would be sample spacing of a coin. And it's very simple. A coin has two faces, okay, and that's head and tails. That's it. That's the sample spacing of a coin. And just like that, if I want to calculate the probability of heads, that would be equal to what? That would be equal to 1 upon 2. If I want to calculate the probability of tails, that would also be equal to 1 upon 2. Okay, when will this be equal? If, let's say, the coin is fair. Okay, fair or unbiased. A lot of times you'll notice this word written, one of the two, fair or unbiased. Okay, इसका मतलब क्या होता है? This means that all probabilities are same. So if you have a fair coin or an unbiased coin, that means the probability of all the outcomes are equal. Okay, if you have a fair die, that means the probability of all the outcomes are also equal. Acha, what's that? Sir, do you have any suggestion for someone who has weaker basic math but have to take? If you have, if your math is not up to the point, then why take it in A levels? I mean, why put yourself through all that? I mean, and if your math is not up to the mark, then I would not suggest pursuing a career which requires a lot of math. Okay. For this, it's best that you speak to a counselor. 1, 2, 3, 4, 5, 6. Okay, so when we roll a die, Ludo sabne khela hoga, theek hai, to usme there are 6 faces, and these are what the 6 faces look like. Okay, now if we were to, let's say, find out the probability of 6, what would that be? That would be equal to 1 upon 6. Why? Because there's only one 6 and there are a total of 6 faces, so that would be 1 upon 6. If, let's say, we were to calculate the probability of even, okay, if let's say we were to calculate the probability of even. So how many even numbers do we have? We have 3 even numbers, divide by the total, which is 6, and this simplifies to what? This simplifies to 1 upon 2. If let's say we were to calculate the probability of 7, that would be 0. Okay, so I'm gonna start writing some key points, okay, and I want you guys to also write them down. Okay, so I'm gonna start writing them over here. Okay, we'll keep on adding to these key points. So key point number 1. What's key point number 1? Key point number 1 is that maximum or total probability is equal to 100%. Maximum or total probability is equal to 1 or 100%. Okay, now why is this important? This is important because if, let's say, you work something out and your answer turns out to be greater than 1, a lot of people, I've seen this happen to a lot of people, that they come out of the examination hall, oh, my probability was so and so was 1.5, 2.8. Bhai, aisa nahi ho sakta. Okay, it's not possible to get probability more than 1 or more than 100%, which are basically the same thing. And just like that, it's also not possible to get probability in minus. Okay, I've heard that from a lot of people also. कि probability जो है वो मेरी minus में आ रही थी. इसका मतलब है that you're doing something wrong. Why? Because if something is not likely to occur, like for example, Pakistan and Australia are playing. Okay, Pakistan has already lost the series. So what would be now the probability of Pakistan losing the series? That would be 0. Okay, there's winning the series. That would be 0. There's no way Pakistan can win the series. They can win the third T20. I don't know when that is, but there's no way Pakistan can now win the series. Okay. Similarly, what would be the probability of Australia losing the series? That would be also 0. And what's the probability of Australia winning the series? That would be 1. Okay. Why? Because it's 100% that they're going to win the series because they've already won 2 games out of 3. Now, another key point is that whenever you see the word or, okay, what you do is you add the probability. Okay, so for example, if there are multiple deep, इसमें क्या deep था भाई? ये तो obvious है. Multiple ways of wait, when was the 30-20? When was the 30-20? Oh, oops, I missed it. Well, I probably lost my interest after they lost the first two. There was no point in watching the third. Okay, so if there are multiple ways of meeting the same requirement, we add the properties. We're going to talk about this later on, okay? Today only, inshallah. I'm writing this down so that I don't forget, and you guys also have a note of it. Another thing is that if, let's say, you see the word and, you see the word both, you see the word all three or something like that, all three, all, then what we do is we multiply, okay? We multiply the probabilities. Okay, now, probability of opposite events, okay? Probability of opposite events. So if, let's say, you're playing a game in which you can only win or lose, so the probability of winning would be equal to 1 minus the probability of losing, okay? If, let's say, the outcome is binary, okay, it's either win or lose, we're not considering draw, but if, let's say, it's a win or lose situation, then the probability of winning is equal to 1 minus the probability of losing. Change your pen, it's hard to read. Really, that's the first time I've heard someone say that. Can you guys not read what I'm writing? Now, this, by the way, can be extended and written as probability of A is equal to 1 minus the probability of A complement, meaning the probability of something happening is equal to 1 minus the probability of it not happening, okay? Where A and A complement are opposite events. Similarly, the probability of, let's say, same is equal to 1 minus the probability of, now what's the opposite of same? Different. Okay, so the probability of same is equal to 1 minus the probability of different. So do you have any suggestions to struggles in odd circle? Acha, don't worry about it. I am streaming very soon, inshallah, probably this Friday, probably. The new topic that has been added in advance, and I'm starting with coordinate geometry of a circle. Okay, so tension knowledge will be starting from scratch. You will, inshallah, not struggle with it after we're done with the stream. So probability of red is equal to 1 minus the probability of not red. Okay, so keep this in mind that कोई भी चीज़ होने की probability is equal to 1 minus उसके ना होने की probability. Okay, so far so good. We've been keeping this pretty simple. Now I will keep on adding to these key points, but before I do that, I'd like us to actually do a question related to sample spacing, okay, where we roll 2 dice and we need to record their sum, okay, and then we'll start pass over questions, okay. So here's the question. The question is that 2 dice are rolled, okay, or thrown or tossed, whatever, and their sum is recorded. Please give one short video on quadratic. Okay, so yeah, their sum is recorded. Okay. Find the probability that, I haven't explained anything, I'm explaining it now. ठीक है, कोई भी चीज़ आपने दोबारा देखनी हो प्लीज़ रिवाइंड करके देख लें instead of me going over it again. Find the probability that, okay, find the probability that the sum is a prime number. The sum is a prime number, okay. Part 2, that the sum is at least, okay, the sum is at least 10. And let's say the sum is at most 5, okay. And last part, that the sum is a multiple of 3, okay. Now before I can answer this question, I need to see what all the outcomes look like, okay. Before I can answer this question, I need to see what all the outcomes look like. So for that, what we'll do is we'll see what the event is. The event is that we're tossing 2 dice and we are recording their sum, okay. So emphasis on the word sum. Now what we need to do is we need to find out the sum or the sum of all possible outcomes, okay. We need to find out the sum of all possible outcomes. So what I'm going to do now is I'm going to do something that's called sample spacing, okay. So what you see horizontally could be all the possible outcomes in one die. Okay, so what you see horizontally, 1 2 3 4 5 6. ठीक है, ये जो आप सब देख रहे हैं, this is D1. Okay, this is die 1. And what you see vertically, पीछे आइसक्रीम वाले की आवाज़ आ रही है. What you see vertically are all the outcomes of die 2. Okay, so these are all the outcomes of die 2, and these are all the outcomes of die 1. Okay, what's this plus sign? This plus sign is telling us that what we need to do to all the scores. Okay, so once we have all the scores in front of us, it'll be easier for us to see how many prime numbers are there, see how many numbers are there that have a sum of at least 10, so on and so forth. Now, while I'm writing down all these outcomes, I want you guys to tell me what will be the total number of outcomes. Okay, tell me the total number of outcomes you think there will be. Okay, so 1 plus 1, that's 2, 2 plus 1 is 3. अच्छा, मैं ये भी बता चलूँ कि हम इसको ऐड कर किस तरह से रहे. So when we're trying to find out what goes over here, we're going to see what we have horizontally and what we have vertically. Okay, so that means D2, one die has 3 and one die has 1, so the sum will be equal to what? 3 plus 1, which is equal to 4. Okay, so that's how I'm writing down these values here. 4 plus 1 is 5, 5 plus 1 is 6, 6 plus 1 is 7, 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, 2 plus 4 is 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10. अच्छा, कैसे निकाला आप लोगों ने 36? 36 is the correct answer. Good job, fellas. Tell me how you got 36. 9, 10, 11, 7, 8, 9, 10, 11, 12. Who would like to tell me how they ended up with 36? Okay, while you're doing that, हम निकालते हैं the probability that the sum 6 times 6. That's correct. So how many outcomes do we have on one die? We have 6 outcomes. How many die do we have on the other? We have 6 outcomes. So 6 times 6. Okay, so this is all the outcomes on die 1 and 6 all the outcomes on die 2, and we multiply them. If let's say we are tossing a coin and we are rolling a die, so how many outcomes would we have then? We would have 12 outcomes. Why? Because coin toss, 2 outcomes, rolling a die, 6 outcomes, so altogether we'll have 12 outcomes. Okay, so we multiply the number of outcomes to get the total number of outcomes. Okay, now the sum is a prime number. Now, what will be the way to find that out? How will we answer this question? Let's see. So here, let's answer the first part. And the way that we're going to do that, the probability that the sum is a prime number is that in the numerator, we'll have all the possible sums that happen to be prime. And in the denominator, we'll have the total, which is equal to what? Which is equal to 36. Okay, so here's what I'm going to do. We already know the total. We know that the total is 36. Now, I'm going to circle every score which is prime. Okay, and that's what I would suggest. I would suggest get a pencil and circle it. Okay, do not count. It's best that you circle it so that you don't end up miss anything. Circle it or put a dot next to it or anything that makes it stand out basically. So we can see that here this is a prime number. Okay, this is a prime number, this is a prime number, this is a prime number. Okay, so 1 2 3 4 5 6 7. I hope everyone knows what a prime number is. Okay, wait, I lost track. 1 2 3 4 5 6 7. ठीक है. 8. Okay, let's do that again. 8 9 10 11 12 13 14 15. Okay, so how many prime numbers do we have? We have a total of 15 prime numbers. Okay, and what's the total number of outcomes? The total number of outcomes we've written already, which is 36. So that means if we simplify, what do we get? We get 5 upon 12. That's it. We get 5 upon 12. That's the answer to the first part. Okay, now let's do part 2. Let's do part 2. Part 2 says the sum is at least 10. Now, what does at least 10 mean? What does at least 10 mean? इसको भी हम की पॉइंट्स में ऐड कर देते हैं. चलें, if let's say the question says at least 10, what does that mean? 5 upon 12. Acha, you're giving me the answer to the previous part. And any other video, can you explain coordinate geometry? Okay, we can do that. So I will be sharing my I'll be taking input from you guys on Instagram. So make sure that you guys respond there. Tell me exactly what you want me to stream, and whichever one has the most request, I'll stream that. Okay. So at least 10 basically means that all values greater than or equal to. Okay, so that means 10 will also be included. Okay, all the sums that are greater than or equal to 10, that's what we're going to consider. Okay, so we're going to do this with the color. Yeah, it can't be less. Okay, not less than 10. It has to be greater than or equal to. So let's circle all the numbers that happen to have a sum of at least 10. This time I'm going to do it using the color red. So 1, 2, 3, 4, 5, and 6. So that's correct. Somebody already gave the answer. So the way that we're going to work this out would be that in the numerator we'll have favorable. Okay, so favorable means that the sum is at least 10. In the denominator we'll have a total number of outcomes. So total remains unchanged. That's 36. In the numerator we have 6. Let's simplify this. What do we get? We get 1 upon 6. Okay. Now the sum is at most 5. What's that? The sum is at most 5. Let's write that down also. At most means, okay, if let's say the question says at most 5, this means that all values lesser than or equal to 5. Okay, at most 5 means lesser than or equal to 5. Now once again I'm going to circle, but this time I'm going to circle using a different color. I'm going to use the color black. Okay, I haven't used the color black yet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have 10. So that means the answer to part 3, once again, favorable upon total. So that's 10 upon 36, which is equal to what? Which is, if we simplify using the table of 2, that's 5 upon 18. There you go. S1 की remaining permutations की मैंने video की तैयारी कर ली है, but I'll make that inshallah tomorrow. We'll post that soon, and then I'll start combinations. Okay. Now part 4, the sum is a multiple of 3. So now I'm going to highlight, since I'm running out of colors, I'm going to highlight with this color all the terms that happen to be multiples of 3. So 3 is a multiple of 3, 6 is a multiple of 3. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 upon 36, which is equal to 1 upon 3. So this is equal to 12 upon 36, which is equal to 1 upon 3. Okay, so pretty easy stuff so far. And the next concept that we're going to do will be related to tree diagram, especially tree diagram without replacement. Okay, so we're going to do that, and then after that inshallah we'll start past paper questions. Like I said, conceptually there's not a lot that you can learn. Just understand the basic concepts and you're good, and then after that we'll start tree diagram. Okay, yeah, 1 upon 3, that's the correct answer. So let's look at tree diagram without replacement. Okay, how to make a tree diagram without replacement. Now what is without? I've been using without, with and without replacement over and over, but what does without replacement mean? So if I start all of AdMaths from today, will I be able to get good grades just by using the book? Realistically speaking, no. I would suggest AdMaths is one of those subjects where it's best that you get some extra help. Okay, I don't think it's possible. See, if let's say you are doing it in school and you're using my channel or resources online for extra help, that's fine. But relying entirely on, I mean, unless you're extremely self-disciplined, then yes. But honestly speaking, if you were extremely self-disciplined, I would say that you would have started by now. So be realistically speaking, no. Yeah, exactly. Without replacement means if you remove something, you don't add it again. So as a result, total goes down. Okay. I do my voting on Instagram. And what we have to do is we have to draw a tree diagram. Okay, tree diagram question is usually around 2 marks. Okay, a tree diagram question is usually around 2 marks. Okay, now let's go back to the key points. Let's add this, that when you're doing a tree diagram without replacement, okay, without replacement means that once you take it out from the bag or the box or whatever it is that you're taking it out from, you don't put it back. Now, why is this important? Because the total decreases, okay? So therefore, the total decreases. Okay, the total number of objects, whatever it is, balls, beads, letters, the total number of objects will decrease, okay? Now, before I make a tree diagram, it's always a good idea to understand how this tree diagram works. Now, imagine this is the bag, okay? And inside of this bag, we have how many? 3 green and 2 red. Okay, so 1, 2, 3. Here's 3 green and here is 2 red. Okay, now. Okay. So we are 2 balls at random. Now, a lot of times after this, the question will say one after the other. Okay, that means you're not drawing 2 at the same time, you're drawing 1 by 1. Okay, I haven't written that, so you'll notice that the question will say that 2 balls, one after the other, are drawn at random, and then whatever the question might follow up with. Okay, so let's make a tree diagram. All right. Now, when we are drawing for the first time, okay, how many outcomes are there? There are 2 outcomes. Okay, there are 2 different outcomes. So that means our tree will have 2 branches. Okay. So here's green and here's red. Okay. Now, what's the probability of taking out a green ball? As you can see, the probability of taking out a green ball is 3/5. What's the probability of taking out a red ball? That's 2/5. Okay, now what's this? This is the first draw. Okay, this is the first draw, meaning that the first ball that you are drawing at random. Okay, now because this is without replacement, that means once you take something out, you don't put it back. So that means if, let's say, I take out a green one, okay, so if let's say I take out a green ball, so here it is. Now it's out of the bag. Yeah, here it is. Now it's out of the bag. Now I'm not going to put it back. Okay. Now, after I take out one green, notice that there are still 2 different outcomes. Okay. One could be green and the other could be red. So that means every branch, in front of every branch, we will draw 2 more branches. Okay. So here we're drawing 2 more branches to represent the 2 unique outcomes. Okay. What are the 2 unique outcomes? Green and red. Now, assuming that the first one turns out to be red, okay, so what we're doing is we're listing all possible outcomes. We don't know whether the first one is going to be green or red. We're just listing all possible outcomes. So if the first one turns out to be green, okay, if the first one turns out to be green, what is the probability that the second one also turns out to be green? So question for you guys. Here's the second draw. What's the probability of getting a green one again? As you can see, how many green balls do we have? We have 2 green balls. What's the number of total? The total is 4. And as you can see, because this is without replacement, the number of green balls has gone down by 1. The total has also gone down by 1. Okay. Why? Because this is without replacement. Now, as far as the number of red balls are concerned, the number of red balls remain the same, 2, but the total goes down. Okay. So irrespective of whether it's green or red that you take out, the total will always go down. Okay. However, the number of red remain the same. Now, this was if the first one turned out to be green, but there's no guarantee that the first one will turn out to be green. It could be red also. So what happens if the first one turns out to be red? Let's see. Let's pull this out. So if the first one turns out to be red, notice once again there are two different colors that we can get. Okay, so therefore, if this branch also will have two different branches, one for green and one for red. Now, because we have taken out red first, that means now the number of green remain the same, that's 3, but the total will definitely go down irrespective, so that's 4. And because we've already taken out one red, now the number of red have gone down to 1, and the total will always go down, and that's 4. Okay. Yes, surds on Wednesday confirmed. I've already posted it on my Instagram story. So we'll see you guys on Wednesday doing surds. Okay. So here is how we make a tree diagram. Now remember, patience is key. Okay. Patience is key. If you're not patient, if you're gonna rush into it, you're definitely gonna mess up. And probability questions are very unforgiving. That meaning that they're 1 or 2 mark questions. You have lots of 1 or 2 mark questions. So if you mess up one, if you make a small error, you lose those marks. Okay, so it's either right or wrong. There's nothing in between. Okay, now let's add some questions to this, and then we'll get to past papers. Okay, so the question is that find the probability that A levels का भी करने का इरादा है. So I will be streaming. Just make sure that you keep checking on Instagram. Whatever I stream, I'll announce it there. Okay. So find the probability that both are green. Okay, so notice what's the word that I've used. I've used the word both. Okay, what do we do in that case? We multiply. So both are green. The only way that can happen is if the first is green and the second is green. That's it. There's no other possibility. Now, what's the probability of getting a green in the first outcome, in the first attempt? That's 3 upon 5. Then what's the probability of getting a green again? That's 2 upon 4. Let's work this out. We get 6 upon 20, which if you simplify, you get 3 upon 10. Okay, pretty simple. Not complicated at all. Now, I'm going to add a part 2. Part 2 is that the first is red and second is green. ठीक है, मैंने restriction लगा दी. Restriction is that the first must be red and the second must be green. So what's the probability of getting a red in the first attempt? That's 2 upon 5. And what's the probability of getting green in the second attempt? That's 3 upon 4. Okay, so 2 upon 5 multiplied by 3 upon 4. Let's work this out. We get 6 upon 20, which if we simplify, coincidentally, we get the same answer. That's 3 upon 10. Please don't make a standard rule out of it. It's just a coincidence. Okay. Now part 3. Part 3 is that one is red and other is green. Okay, one is red and the other is green. So, कोई बताएगा मुझे इसका क्या मतलब है? How is part 3 different from part 2? Yes, I will be doing AdMath streams also. Inshallah, I will be streaming starting with circular, not circular measure, but coordinate geometry of a circle. I'll be starting with that. Don't forget about M1. Okay. Too many streams, very little time. Let's see what happens. So anyone who'd like to tell me the difference between part 2 and part 3? Any news related to the 2026 paper? No news. I hope you're not expecting it to get cancelled or something. Yeah, exactly. So the difference is that in part 3, in part 2, we have been told the order. That means the only way part 2 can happen is red-green. That's it. This is the only way that part 2 can happen. Okay, as far as part 3 is concerned, it could be red-green. Okay, or it could be green red. Okay, so remember what I wrote earlier in key points, that whenever there are multiple ways of meeting the same requirement, we add the probabilities. Okay, so there are two ways that through which we can meet the requirement. So what we're going to do is we're going to add the probabilities, and also because the word is or. So we already know the probability of red green, which is worked it out. That's 3 upon 10. What about the probability? What about the probability of green red? So green red, as you can see, we'll have to work it out. So that's 3 upon 5 into 2 upon 4. Okay, 3 upon 5 into 2 upon 4, which will be the same as the previous one. That means also 3 upon 10. So this will turn out to be 6 upon 10. And if you simplify that, that's equal to 3 upon 5. Okay, now part 4, the second last part. Okay, second last part, then another part, and then we're doing past paper questions. Both are of the same color. Okay, both are of the same color. Now, once again, how many ways can we fulfill this requirement? Part 3 will be not a 3 mark, but a 2 mark question. Okay, now how many ways can we fulfill this requirement? We can fulfill this requirement 2 ways. One is green, green, okay, or red, red, okay. So green, green would be something that we've already worked out. That's 3 upon 10, okay. And then as far as red, red is concerned, that's 2 upon 5 into 1 upon 4. 2 upon 5 into 1 upon 4. So let's work this out. The final answer, I'm going to write down the final answer to save some time. And that's going to be 2 upon 5. Okay. Okay, now last part before we move to actual past paper questions. Both are of different color. कोई बताएगा इसका जवाब? How will we work out the probability that both of them are of different color using the easier method? What's the step up from O level probability to A2 S1? A huge step up. I mean, it's a different ball game altogether. 1 minus, that's correct. So probability of different, as we saw earlier, can basically be worked out 1 minus the probability of same. Okay, we've already worked out the probability of same, that's 2 upon 5, and the answer is 3 upon 5. Okay, so sir is in part 3 and part 5 coincidentally happen to be asking us the same thing. So you're right. Now, let's do some past paper questions. Okay, now you will find this worksheet. It's in the description. You'll find a link there. There you will find this worksheet. Okay, I'm going to solve it now. So pay close attention. Let's solve the first question. This is from IGCSE. Okay, so you'll find a mixture of questions. Some questions from IGCSE, some questions from O level. Okay, but you have to focus on the concept, not on the question. Okay, so this is a question of tree diagram, okay, and a tree diagram which is neither with or without replacement. This is actually two separate categories. Okay, so as I wrote down earlier, this is also a tree diagram, but this is a tree diagram of two separate events. Okay, it's not like you're taking two of something out from the same bag. No, these are two separate events altogether. Okay, so let's see how this works. Dan either walks or cycles to school. The probability that he cycles to school is 1 upon 3. So if the probability of cycling is 1 upon 3, what would be the probability of not cycling? Okay, which is walking, because there's no third possibility. Okay, there's no third way that he's going to get to school. He can't drive to school, he can't fly to school, he either walks or cycles. So if the probability that he cycles is 1 upon 3, the probability that he walks would be 1 minus 1 upon 3, which is equal to 2 upon 3. Okay, so the probability that he walks is 1 minus 1 upon 3, which is 2 upon 3. Okay, so in case you're wondering how I got this, we got this by doing 1 minus 1 upon 3. Okay, got an A star in math. Okay, I'm extremely happy to hear that. Sir, can you reduce the slow motion by 5 seconds? Oh yeah, I think that is something from before. Let me fix that. Okay, let's get through this question, then I'll... yeah, wait a minute. I'll just fix it right now. Just a second. Okay, done. Sir, please do a spinner. Okay, I'll do a spinner question. Don't worry. So, the probability that he is late... okay, now let's read the question further. Write down the probability that Dan walks to school. So we've already done that. Okay, we've already done the first part. The probability that he walks is 2 upon 3. Okay. Then the question says, when Dan cycles to schools, the probability that he is late is 1 upon 8. So when Dan cycles to school, the probability that he is late is 1 upon 8. What would be the probability that he is not late? That would simply be 1 minus 1 upon 8. Okay, so this would be 1 minus the probability of late, which is going to be equal to 7 upon 8. Then if we read the question further, when Dan walks to school, the probability that he is late is 3 upon 8. So what would be the probability that he is not late? That would be, once again, 1 minus the probability that he is late, which is going to be 1 minus 3 upon 8, and that is 5 upon 8. Okay? Mustafa, even if you're late, you can always rewatch the stream later. Okay? It's not a live class. I mean, technically it is a live class, but you can always rewatch it. Okay, so we have done, we have completed the tree diagram. How many marks do we get for that? We get 2 marks. We get 1 mark for finding out the probability that he walks. Okay, now every question that we will do will require us to use the tree diagram. Okay, that's how you'll notice most of the questions are structured. First, you'll have to find out some probabilities, plug them in the tree diagram, and then do all the questions that are related to that tree diagram. Okay, so first part. Calculate the probability that Dan cycles to school and is late. So Dan cycles to school and he is late. So the key word is and, which is why we will multiply their probability. So in the first part, the probability that he cycles and he is late, meaning the probability that he is late when he cycles. So the probability that he cycles is 1 upon 3. The probability that he is late is 1 upon 8. So the answer is 1 upon 24. Okay, can you make a... yeah, that is something I plan on doing, so I will most likely do that, don't worry. Okay, now let's do part 2. The part 2 is Dan is not late. Okay, so how many ways can Dan not be late? Inshallah, Monday, Wednesday, I will be streaming maths. Not Tuesday, but for Thursday, inshallah, I will be streaming ad maths. Okay, and Friday also, most likely, I'll be streaming ad maths. At what point would you suggest a person to drop ad maths? Oh, ये कौन? Night howlers, मुझे लग रहा है काफ़ी पीछे चलना है. At what point would you suggest that a person drop ad maths? देखो, here's a simple way that you can decide that. Keep on studying the subject till it's time to register. At that point, see whether you're in a position of giving the subject in May, June. If not, then don't do it. Okay, don't put yourself under unnecessary stress, especially over a subject which is something that you don't have to give. You can give some other subject. As far as math is concerned, definitely you should make sure that you're stressing over that. That's important. But rest, you don't have to. Mustafa, मैंने recently, कल ही in fact उस पे video डाली है. You can check it out. Okay, I posted a video on exact trigonometric values. You can check it out. Okay, so part 2, probability that Dan is not late. So the way that he cannot be late is that he cycles and he is not late. Okay, so this is one way that he cannot be late. And the other is that he walks and he is not late. Okay, so all the number of ways that he is not late is this. That he cycles and not late. इसकी probability निकालेंगे हम. Okay, or the probability that he walks and he is not late. Okay, we're going to find out the probability of this also. So what's the probability that he cycles? That's 1 upon 3. And then what's the probability that he is not late? That's 7 upon 8. Plus the probability that he walks, that's 2 upon 3 into the probability that he is not late. If he walks, that's 5 upon 8. Let's see, what do we get? 7 upon 24 plus 10 upon 24, which is equal to what? 17 upon 24. There you go. You're welcome, Mustafa. Okay, so that was one question, one very basic question. Let's try and do some more questions, and then we will gradually start increasing the difficulty level as well. Okay, here's another question. Let's see what this one says. The probability of a cricket team winning or losing in their first two matches is shown in the tree diagram. Once again, these are tree diagrams that have two separate categories. Okay, this is neither with nor without replacement. These are two separate categories that we're dealing with. Okay, let's see what the question says. Find the probability that the cricket team wins at least one match. Okay, so the keyword here is that the cricket team wins at least one match. These are the keywords. Now, what does at least one match, win at least one match mean? What would be the opposite of it? What does the probability of at least wins at least one match equal to? Should I drop add maths? It's way too hard. It is definitely difficult, no doubt about that, but if you want to pursue something which requires you to do add maths, then obviously don't. If not, then yeah, go ahead. It's best that you focus on the subjects that you really need a good grade in. So, the probability that he wins at least one match could be that he wins, okay, could be win-win, okay, or, okay, remember whenever we say or, we mean plus. Win-lose or lose-win. Anything else? No, that's it. Okay, now let's do it this way, and then I'll show you guys an easier way also. Okay, so what's the probability of winning both the matches? That's 1 upon 3 into 3 upon 4. Okay, whatever that is equal to. Plus the probability of winning and losing, winning the first match and losing the second match, that's 1 upon 3 into 1 upon 4. Plus the probability of losing the first match, which would be 2 upon 3, and then winning the second match, which would be 3 upon 4. Okay, so what do we get? We get 3 upon 12 plus 1 upon 12 plus 6 upon 12. So 3 plus 6 is 9, 9 plus 1 is 10, 10 upon 12. That's the answer, which when you simplify, you get 5 upon 6. Okay. Now, what if I told you that there's an easier way? Even though it's a 3-mark question, but what if I told you that there's an easier way? So make sure that you pay close attention. Alternatively, is that how you spell alternatively? Yeah. Here's what you can do. What would be the opposite of wins at least one match? Wins at least one match. इसका opposite क्या होगा? इसका opposite होगा exactly 1 minus the probability of losing both or not winning at all. Okay? Probability of winning at least one would be 1 minus the probability of not winning at all, which means probability of losing both. So if I do that, let's see if we get the correct answer. 1 minus the probability of losing both would be 2 upon 3 into 1 upon 4. 2 upon 3 into 1 upon 4. So what do we get? We get 2 upon 12. So 1 minus 2 upon 12 is equals to 10 upon 12, which in fact is once again equal to 5 upon 6. Okay? So you have two methods in front of you. They're both equally applicable. They're both equally legit. Now you guys can decide what method is it that you want to stick to. Okay, now let's do a slightly different question. This is from O-levels, and it's not your usual tree diagram kind of a question. It's slightly different. Let's see what it says. Okay, so it says a bag contains red and blue pegs. There are 40 pegs in the bag. The probability of choosing a red peg is 0.4. Work out the number of red pegs in the bag. Sir, what to do with probability? I can easily do all three diagrams. Okay, we're doing one right now. Okay. Now, the question says that the total pegs, okay, the total pegs are 40, okay, and the probability of choosing red, according to the question, is 0.4. Now, what's the way that we will calculate the probability of choosing a red peg? That would be the number of red pegs divided by the total, which will give us the probability of red. Okay, now we already know what the total is. The total is 40, which is equal to 0.4. 40 into 0.4 equals to 16. So that means the number of red pegs happen to be 16. Okay, now let's do part B. Part B says more red pegs are added to the bags. Work out the number of red pegs that must be added to the bag so that the probability of choosing a blue peg is 0.2. Okay. Now, how will we work out the by the way, previously, what were the number of blue pegs? Okay. So, previously, the number of blue pegs was equal to 40 minus 16, which is equal to what? Which is equal to 24. Okay. So, this was previously, before there were more blue pegs added. Okay. Red pegs added. In fact, this will remain the same. Okay, this will remain the same. Sorry, my bad. This remains the same. I don't know if this is even relevant. Let's find out. Let's find out. So the question says that the probability of choosing a blue peg, yeah, it is relevant actually. The probability of choosing a blue peg is equal to 0.2. Okay. Now, if you read the question says work out the number of red pegs that must be added to the bag so that the probability of choosing a blue peg is 0.2. So that means the number of blue divided by total is equals to 0.2. Now, as far as the number of blue pegs are concerned, that remains the same. Okay, but as far as total is concerned, total earlier was 40. Now what we're doing is we're adding red pegs. Okay, so let's call the number of red pegs that we're adding R, and this is equal to what? This is equal to 0.2. Okay, now let's simplify. 24 equals to 40 into 0.2, so that would be 8 plus 0.2R. Now 0.2R is equals to 24 minus 8, which means 0.2R is equals to 16. And let's find out R. R is equals to 16 divided by 0.2. If you simplify this, that means multiplying the numerator and the denominator by 10. That's 160 upon 2, which is equal to what? Which is equal to 80. Okay, so I'll explain this again. Now make sure that you understand the question really well. The question says that more red pegs are added to the bag. Okay, so that means the number of blue remains the same, that is 24. How did I get 24? The number of red are 16, total is 40, so blue is equals to 40 minus 16. Now you're adding red pegs to a point where the probability of choosing a blue peg becomes 0.2. Okay. So how will you calculate the probability of choosing blue? That would be the number of blue pegs divided by the total. The number of blue pegs remain the same, that's 24. The total, however, will be 40 plus R. Okay, 40, that's the total earlier. Now you've added R red pegs, so this adds to the total, and this gives you the probability of choosing a blue peg, which is 0.2. Cross multiply, get your answer. Okay, I hope it's clear now. Let's see, let's do some more questions. Okay, I have another question from this worksheet to solve before we move on. This is a fairly easy question. Let's do this. Yes, why are you watching this? I should be the one asking you this question. Okay, go ahead, attempt this question. I'll give you guys a few minutes to solve this question without my help. Yes, I went for Umrah. I just got back. Actually, no, not just got back. It's been a while. आज के date है 18th. I got back. Okay, I don't remember. I think it's been 2 weeks now. But yes. Sir, I have watched all your videos. I study in Jaipur and I just see school. Okay, I'm glad. I hope the videos are helping. Veer Rahul, best of luck for your exams. Okay, so do we have the answer? Do we have the answer to part B? Probability that Jim's team wins their next match? Let's see. I'm going to solve this quickly. Jim plays for his local football team. The probability that Jim plays in the next match is 0.7. Okay. If Jim plays in the next match, the probability of his team winning is 0.8. So the probability of not winning would be 0.2. Okay. So if the probability of Jim playing is 0.7, the probability of Jim not playing would naturally be 0.3. And then the probability of not winning would be 0.4. Calculate the probability that Jim's team wins their next match. That would simply be 0.7 into 0.8. So with Jim, okay. And then the probability that he does not play but the team still wins. There you go. So 0.7 into 0.8 would be 0.56. This would be 0.18. And let's see what the answer is. This is going to be 0.46474. Yeah, so 0.74. There you go. So I hope that's clear. Let me see if there is another question that we should solve from this worksheet. When it goes, no, I don't think we should. I think we should now move on to the next worksheet, which has some more complicated questions. And these are questions that I would like to solve. This is a good question. Make sure you're reading the question extremely carefully. Okay. So although this is tree diagram, but this is still a tricky question. Let's see what it says. So it says a bag contains 5 balls, of which 2 are blue, 2 of which are blue and 3 are red. One ball is taken at random from the bag. If it is red, it is put back into the bag. If it is red, it is put back into the bag. If it is blue, it is not put back into the bag. Okay, so this is kind of with as well as without replacement. Okay, it's a bit of both. Part of the tree diagram that represents these outcomes is drawn below. Okay, complete the tree diagram, express each answer as a fraction in its simplest form, find the probability that both balls taken are blue, the second ball taken is blue. Okay, now, according to the question, only if it's red do we put it, if it is red, it's put back into the bag. Okay, if it is blue, it's not put back into the bag. So which is why you can see that after we take out one blue, the probability of taking out blue again goes down. Okay, because the number of blue go down and the total goes down. But if we take out red, okay, if we take out red, then what does it mean by saying that it is put back into the bag? Iska kya matlab hai? What happens when you put something back into the bag? Question for you guys. What if I put it back into, what if I take out a red and then I put it back into the bag? What happens as a result? Sir, my name is Veer. Rahul is my middle name. Okay. You're welcome, Veer. Two upon 4 red. Nope. I'm afraid not. It would be the same. It would be the same as this one. Why? Read the question. The question says that if it is red, it's put back into the bag. Okay, so that means if it is red, we put it back into the bag. So that means now, even if you're taking out for the second time, the probability of getting red would still be 3 upon 5. Okay, the probability of getting red would still to the bag. Okay, I may be lagging, but I think it's fine now. Okay, now let's, using the tree diagram, now let's solve the remaining parts. Okay, so part 1. Part 1 says expressing, let's do part B. Part B says expressing each answer as a fraction in its simplest form. Find the probability. Is 2 upon 5. The probability that the second one is blue is 1 upon 4. So what do we get? We get 2 upon 20, which upon simplifying becomes 1 upon 10. Okay. Now let's talk about the second part. The second part says that the second ball taken is blue. Now, the second ball taken is blue means that the first one could be anything. That means it could be blue blue, okay, or it could be red blue. Okay, as long as the second one is blue, that's all that matters. Okay, so blue blue, that would be 2 upon 5 into 1 upon 4, plus red blue, that would be 3 upon 5 into 2 upon 5. Okay, so let's work this out, see what do we get. 2 upon 20 plus 6 upon 25. Do keep in mind that this is a paper 1 question. You guys know what that means. That means no calculator. Let's simplify before we add them. So this becomes 2 upon 10. 6 upon 25 sadly cannot be simplified. So the LCM of 10 and 25 would be 50. So we'll multiply this by 5. This also gets multiplied by 5. So that's 5. This gets multiplied by 2. Probability worksheet 2. Yeah, that is the correct answer. Okay, great. So that was one question. Let's try and solve more questions similar to this. This is another one of my favorite questions. Another very challenging question of probability. In some questions, why do we multiply by 2? We multiply by 2 because there are 2 ways that can happen. Okay, and the probability of both the ways are the same. So that is when we multiply by 2. Just for example, abhi humne ek question kiya tha where the question said that one is red and the other is blue. Okay, now in that case, the probability of red blue was the same as the probability of blue red, irrespective of the order. So in that case, we can just find out the probability of one way and multiply it by 2. Okay, but that doesn't work all the time, which is why it's best that you figure it out separately and then do it. Okay, like for example here, if let's say the question was that one is red and the other is blue, so if we find out the probability of blue red and then if we find out the probability of red blue, they would both be different, so we can't multiply it by 2 here. Okay, all right, next question. Like I said, this is another one of my favorite questions. You guys will find out exactly why that is. It's not your usual tree diagram question. Okay, it's not your usual tree diagram question. It's a slightly complicated one. So it says, let's read the question. It says a bag contains 5 balls, of which 3 are red and 2 are blue. One ball is taken at random from the bag and is not replaced. If the ball is red, another ball is taken at random from the bag and is not replaced. The process is repeated until a blue ball is taken from the bag. Okay, so that means the reason why we don't see any branch in front of blue is because as soon as you take out a blue ball, the whole event just stops. Okay, and then so if it comes out in the second attempt, if the second ball turns out to be blue, you stop here. If the third one turns out to be blue, then what you do is you stop. Okay, however, if it's red, then you carry on drawing. Okay, if it's red, then you carry on taking out balls from the bag until you get a blue one. Okay, so how do we do this? How do we complete the tree diagram? So let's get the tree diagram in one place. Here it is. Here is the tree diagram. Okay, so we can see what the first two draws look like. Okay, so here's the first part. We can already see what the first two draws look like. Let's extend it further. Okay, so make sure that you guys are paying close attention and make sure that you've all understood the question clearly. Okay, I'll repeat. The question is that the question says that if it is red, another one is taken. If it is blue, it is not. Okay, the whole process is repeated until a blue ball is taken from the bag. Okay, so that means we will only draw branches in front of red. Okay, and when we are drawing for the third time, okay, when it's time to take out the third ball, then what would be the probability of red? Let's see. So in the first attempt it was 3 upon 5. Now the number of red went down, the total went down. Okay. The number of blue is 2 upon 5, and then in the second ball, in the second attempt, the number of blue remained the same, but the total went down. Okay, so the total will go down irrespective, but the number of blue will remain the same. Now, when we are taking out the third ball, the probability of drawing a red would be 1 upon 3. Why 1 upon 3? Because previously there were 2 and total were 4. Now, if you take one out, that means now you have 1 red and the total is 3. And as far as blue is concerned, that would be 2 upon 3. Okay, the number of blue remained the same, but the total goes down. And then for the fourth ball, okay, here's the fourth one. The probability of taking out a red would be 0 upon 2. Okay, because the total are now 2 and there are no red balls left. But the probability of taking out blue would be 2 upon 2. Okay, and that means the maximum number of times that you need to take out balls from this bag is 4, and in the fourth attempt, you will definitely get a blue one. Okay, so we have completed the tree diagram. How many marks do we get? We get 1 mark. And once you have made the tree diagram, everything else is downhill. Let's do the first part of B. Expressing each answer as a fraction, find the probability that the second ball taken is blue. So the only way that can happen that the second ball is blue is if the first one is red. Okay, there's no other way. So what's the probability of the first one being red? That's 3 upon 5. And what's the probability of the second one being blue? That's 2 upon 4. Let's work this out. That's going to be 6 upon 20, which is equal to 3 upon 10. Okay, yeah, this is my first math live stream for this year, O levels. Yeah. Now, part 2. A blue ball is second or the third ball taken. Okay, so as far as the second is concerned, we've already figured that out. Okay, we already know the probability of this is 3 upon 10. But the third one, how can a blue ball be the third one? That is if the first 2 are red. Okay, so the only way that a blue ball could be the third one is if the first 2 are red and then there is blue. Okay, so this is how the third one can be blue. Okay, so the probability of red in the first attempt is 3 upon 5. In the second attempt, 2 upon 4. In the third, it should be blue, which is 2 upon 3. Okay, so let's work this out, see what do we get. So we can cross out this 3 with this 3. 2 1s are, 2 2s are. So this would be 2 upon 10. So 3 upon 10 plus 2 upon 10 is 5 upon 10, which is equal to 1 upon 2. And there you go. That is the answer. Okay, let me see if that's correct. Yeah, that is correct. Okay, great. Now let's do a few more questions. Here's a spinner question. Somebody requested to do a spinner question, so here it is. Oh yeah, 2 upon 2, sorry. Could have lost a mark there. Correct answer is 2 upon 2 or simply 1. Thank you for pointing that out. Yes, I will be doing AdMath streams, inshallah, starting from Thursday. Okay, Thursday I will be streaming, what am I streaming? Coordinate geometry of a circle. Okay, something that has been recently added to the syllabus. So here's a spinner question. Let's see what this is. So it says a fair four-sided spinner. So the spinner is fair. Okay, that means the probability will be equal. Is numbered 1, 2, 3, and 4. Anil spins it once. He gets his score by doubling the number obtained. Complete the table to show the probability of his scores. Okay, so all he's doing is doubling the number obtained. Okay, he's only spinning it once. So that means if he gets no, wait a minute. Complete the table to show the probability of his scores. No, wait, there is something. I guess there's something wrong with the question. Okay, I guess इसका table ही नहीं दिया हुआ. खैर कोई बात नहीं. We'll make a separate table. Okay. So here, in fact, let me just open up this question. Just a minute. Just a second. Don't go anywhere. Okay. This is the table that's missing. Khair, it's really not that big of a deal, but here it is. Here's the answer to part A. Okay, in part A, we have to complete the table. Which table? Here it is. 2, 4, 6, 8. Now, the only way that he will get a 2 is if the spinner shows 1. The only way that he'll get a 4 is if the spinner shows 2. The only way that he'll get 6 is if the spinner shows 3. The only way that he'll get 8 is if the spinner shows 4. Okay. Now, since it's a fair spinner, that means the probability would be 1 upon 4, or simply, in fact, let's write it in fraction form. So 1 upon 4, 1 upon 4, 1 upon 4, 1 upon 4. Okay, that's it. That's the answer to the first part. Okay. Billy spins it twice. She gets her score by adding the numbers obtained. Complete the possibility diagram. Okay, so 4 plus 1 is 5. 4 plus 2 is 6. 4 plus 3 is 7. 4 plus 4 is 8. Simple as that. Okay. Complete the table showing the probability for sum of Billy's scores. Okay. So greater than 2. Now, why is the probability of greater than 2 15 upon 16? That's because there are a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are a total of 15 scores out of 16 that happen to be greater than 2. Now, if the question is asking for greater than 4, let's see how many scores do we have that are greater than 4. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the answer is 10 upon 16. How many scores are there that are greater than 6? Let's see. 1, 2, 3. So what do we have? We have 3 upon 16. And then how many scores do we have that are greater than 8? Well, no scores. Okay, so the answer would simply be 0. Okay, so this is not your usual question. It's not something that we get very often, but it's not that difficult nonetheless. Let's make sure our answers are correct. Yeah, 15 upon 16, 10 upon 16, 3 upon 16, and 0. Okay, now here's part C. Part C is find the probability that Billy scores more than Anil. Okay, so this is a question. This is a part which has troubled a lot of students. That Billy scores more than Anil. That means if Anil scores 2, which he can, okay, then Billy should score more than 2. Okay, or if Anil scores 4, then Billy should score more than 4. Okay, or if Anil scores 6, then Billy should score more than 6. Most likely in paper 1, but sometimes in paper 2 also. Or finally, if Anil scores 8, then Billy should score more than 8. Okay, so what's the probability that Anil scores 2? That's 1 upon 4. And what's the probability that Billy scores more than 2? That's 15 upon 16. This I think is, okay, this is also a paper 1 question. All right. Or that means plus, what's the probability that Anil scores 4? That's 1 upon 4. And then what's the probability that Billy scores more than 4? That's 10 upon 16. Okay, so the question has sort of made you figure out every relevant piece of information already. Now, what's the probability that Anil scores 6? That is also 1 upon 4. And the probability that Billy scores more than 6 is 3 upon 16. What's the probability that Anil scores 8? Also 1 upon 4. The probability that Billy scores more than 8, that's 0. Okay. So we're going to keep the denominator as it is. We're not going to simplify it, okay? Otherwise, adding it would become difficult. So 16 times 4 is 64. So that's 15 upon 64 plus 10 upon 64 plus 3 upon 64 plus 0. So 15 plus 10, that's 25. 25 plus 3 is 28. So 28 upon 64, which I believe we can simplify using the table of 4. 4 sevens are, and 4 16s are. And there you go, fellas. That is the correct answer. So 7 upon 16 is the final answer. Any questions? If yes, do let me know. How the questions will come is something else. Okay, we'll find that out. But for now, don't worry about the questions, focus on the concept. Okay, question इसी तरह का होगा where you might have to evaluate one of the values, sine 30, 60, 45. Okay, and you'll have to do that without a calculator, nothing else. Okay, last question, and then after that we'll stop, inshallah. And this is a difficult question. If the question says simplify and you don't, if the examiner says anything and you don't do it, the examiner has the right to cut your marks. Simple as that. Okay. Now here's question number 4. Let's see what it says. It says box 1 contains 2 white balls, box 2 contains 4 white balls and 3 black balls. Find the probability that these balls are both black. Okay, I forgot this part, that Anne chooses one ball from each box. Find the probability that they're both black. Is that possible? Is it possible to get both of them to be black? Well, not really. So the answer to A part 1 is going to be 0. Okay, why? Because it's not possible that you get a black one from box 1, even if you can from 2, but it's not possible from both. Part 2. Find the probability that these balls have different colors. So the only way that can happen is if the first one is white and the second one is black. There's no other possibility. So what's the probability of getting a white one from the first box? That's 2 upon 2. Then what's the probability of getting a black one from the second box? That would be 3 upon let's see, 4 plus 3, that's 7. So the answer to that is simply 3 over 7. Okay, so the first two parts are fairly easy. The last part of this question is slightly complicated. Okay, now let's do part B. Part B says, from the original contents of box 2, B chooses at random 2 balls without replacement. Find the probability that these balls are both white. Okay, so that means the probability that they're both white, you don't really have to make a tree diagram here. You can simply count that the probability of getting white is 1, 2, 3, 4. I got back from Umrah. I didn't get bored for no reason. I got back from Umrah last month. That's why. 4.7, the getting white in the first one. And then the probability of getting white again is 3 upon 6. So let's see what's that. 3 1s are, 3 2s are, 2 1s are, 2 2s are. So the answer is 2 upon 7. Okay. So 4 upon 6 into 3 upon 4.7 into 3 upon 6, that's 2 upon 7. Okay, part C. Thank you. Part C is Carla chooses one of the boxes at random with the original box contents. She then chooses at random one ball from this box. Find the probability that the ball is white. Okay. Now notice that she's choosing one of the boxes at random also. Okay. So that means it's possible that she chooses box 1 and she gets a white ball from that box, or it's possible that she chooses box 2 and gets a white one from that box. So what's the probability that she chooses box 1? So there are 2 boxes. It's equally likely to choose 1. That's 1 upon 2. And from that box, what's the probability that she gets a white ball? That's 2 upon 2. Similarly, the probability that she chooses box 2 is also 1 upon 2. And from that box, what's the probability that she gets a white ball? That's going to be 4 upon 7. Okay, so we have 1 upon 2 plus 2 1s are, 2 2s are, 2 upon 7. 1 upon 2 plus 2 upon 7. Let's add this. So the LCM of 2 and 7 is going to be 14, We multiply this by 7, this by 7, that's 7. This by 2, this by 2, that's 4. So 7 plus 4 is 11. So 11 upon 14 is the answer. Let me make sure of that. Yep, there you go. Now, as always, take a good look at it, and I hope it's clear. So we're going to keep it till here only. I hope you guys have understood the basics and the questions that I solved. I will encourage you guys to download the worksheets. You'll find a link of both the worksheets in the description. Download the worksheets, solve them for practice. Maybe later on we'll do another stream solving all the difficult probability questions, but more or less the difficulty level of probability question will remain the same. There are some questions where in IGCSE especially, where you'll find some really difficult probability questions. I'll maybe do a separate stream on that, but this is enough for you guys to start practicing. Okay, so I will stop here. Where should I practice O level? Dekho, as far as O level ad maths paper 1 is concerned, the simple way to practice that is to not use a calculator in every question till you reach a point where you absolutely have to. Okay, so if you reach a point where you absolutely have to use a calculator, then use it, otherwise don't use it. Simple as that. Okay, so I will stop here. See you guys inshallah on Wednesday. I'm streaming surge and exponential growth and decay of O levels, something that has been recently added in O levels and something that has always been a part of IGCSE. Okay, so take care fellas, see you on Wednesday. Allah Hafiz.